Welcome to Physics and Me. So today let's learn how to find the normalization constant. It's one of the very important concept. Okay, so in CSR exams, that is net exams, and in KSR exams, even in GATE exams, so there is a chance of asking these questions. Okay, to find the normalization constant, or while solving the problems, it will be necessary for you to find the normalization constant, and then you have to solve the problems. So it takes some time. Okay, to solve the integral. So today I'll give you a trick. Okay, so we'll solve by the trick. So under which you can solve under 30 seconds itself. Okay, so let's learn that trick. Okay, well, the condition for normalization is given by minus infinity to plus infinity psi star psi into dx, which is equals 1. Well, so minus infinity to plus infinity, these are the limits. Okay, psi is a wave function, the given wave function, for which we have to find the normalization constant. So psi star is nothing but its complex conjugate, and it should be equals to 1. So normalization is nothing but its total probability it will be equals to 1. Well, so now let's consider an example. Okay, by usual method, how you will solve the normalization constant. Okay, so let's solve for 1D box, that is 0 to L infinite 1D box. Okay, so the potential inside the well is 0 and its outside is infinity. Okay, so another important thing is that, so this is one dimension dx. Okay, if it's a 3 dimension, then it will be dx dy dz. Okay, so the range of dx is, that is x is 0 to infinity, same 0 to infinity, and dz also 0 to infinity. Okay, this is for Cartesian coordinates. If it's a spherical coordinates, then r theta phi. Okay, so that is r square dr sine theta d theta into d phi. Okay, so the range of r is, that is from 0 to infinity, and theta, that is 0 to pi, and d phi 0 to 2 pi. And similarly, if it's a cylindrical coordinate, that is 3 dimension, then rho d phi, that is rho d phi dz. So this is for cylindrical coordinates. Well, okay, so let's consider 1D box, infinite potential 1-dimensional box. Well, so its wave function is given by, for nth state, under root 2 by L sine n pi x by L. Okay, so this is the normalization constant n, and we have to find this constant. Now we know that one. Okay, so let's find this normalization constant. So suppose psi n is equals to n sine n pi x by L. Okay, so let's find this n now. Okay, the answer is root 2 by L. Okay, we'll find this one n by usual method itself. After solving by usual method, I'll tell you the trick. Okay, so the limits are 0 to L. Okay, we should not take minus infinity to infinity. Whenever the limits are not given, at that time you have to take minus infinity to plus infinity. 0 to L. So the psi is that is only n sine n pi x by L. Okay, so psi star psi is there. Okay, so another thing is that this can also be written as minus infinity to infinity mod psi square into dx is equals to 1. Okay, therefore n square sine n pi x by L, n square sine square pi n pi x by L into dx, which is equals to 1. Okay, 0 to L. So n square is a constant, take it outside. 0 to L sine square n pi x by L into dx equals to 1. Okay, so there is no need of further simplification. Okay, so there is a trick, so that whenever you have sine square or cos square terms, so and you have the limits as full integral or half integral limits, at that time only we can directly substitute that n square into 1 by 2 into length of the interval. Okay, so whenever you have sine and cosine terms in the power of like this sine square cos square, and you have the full interval limits or half interval limits, at that time only you can directly write half into length of the interval, that is 1 by 2 into length of the interval is L, that's it, which is equals to 1. Okay, next, which implies n square is equals to L by 2. Okay, so it will be 2 by L, so cross multiply this side, 2 by L, finally we will get n equals to root 2 by L. Okay, finally you will get n equals to so take this square and shift towards the right side, and you will get root 2 by L, so which is a normalization constant as we have stated. Well, whenever you have given 1D box and you have to find the normalization constant, the trick is that n equals to under root 2 by L. So L is nothing but the length of the box. Whatever may be the length, just substitute under root 2 by L. That will be your normalization constant for 1D box. So this is a trick. So there is no need of doing the integration and finding the constant. Simply it's a waste of a time. Okay, so let's take one example. 0 to L by 2. Okay, 0 to L by 2. So infinity. So you have to find the normalization constant for this 1D box. Okay, so finally, by using the trick, under root 2 by 2 is a constant. Okay, length, so here length is L by 2. Okay, so L by 2, so I can send this 2 to the numerator, right? Okay, then what it will be? Under root 4 by L, which equals to 2 by root L. So this will be a normalization constant for length 0 to L by 2. Okay, so let's take one more example. Consider a 1D box of an infinite potential. Okay, 0 to 3L. Okay, this time 3L. N is equals to under root 2 by length of the box is 3L. Finish. So this is your normalization constant. Okay, so let's take one more example. Minus 2L plus 2L. Okay, so now the length of the box is 4L. Minus 2 to 0 to L, 0 to 2L, so totally 4L. So the length of the box will be 4L, this time 4L. Okay. So this is another example. Okay, minus 2L to plus 2L, this is the length of the box, so totally 4L. So under root 2 by length of the box is 4L. 2 1s are 2 2s are. Therefore 1 by root 2L is your normalization constant. So this is a trick for 1D box. So whatever may be the length, so just apply this trick, so you'll get the normalization constant.